Okay, so in this video we're going to take a look at exactly what an atom is, atomic structure in terms of protons, neutrons and electrons, how we draw these in diagram form, and the difference between different atoms in the periodic table. So first of all, we need to realise that everything is made of atoms. So if we have a human being, it's a great drawing here, you've got a stick man. Right, this guy's made up of trillions and trillions of cells, which you'll learn about in biology, of course. But if we zoom in, let's say we zoom in here, every single cell is made up of millions and millions and millions of atoms. And in us, they're mostly carbon, hydrogen, oxygen, nitrogen. But what an atom actually looks like is you have a nucleus. Let's say this here is the nucleus. Don't get this confused with the nucleus that you'll learn about in biology. The nucleus really just means the core of something. So the core of a cell is the nucleus, which contains DNA, which you learn about in your biology course. The core of an atom is known as the nucleus, and that contains protons and neutrons. So let's do them in different colours. Protons will be in there in red. Neutrons are going to be in there in green. Neutrons, and buzzing around the nucleus are going to be electrons, which I'm going to draw in yellow. Now let's pretend that this is a carbon atom. What we have in carbon is 6 protons, 3, 4, 5, 6, and 6 neutrons. And remember, protons and neutrons are found in the nucleus. So that is 6 and 6. So this is the nucleus of a carbon atom. And important to note is that the number of electrons is going to equal your number of protons. So in an atom, it's different when you speak about ions, which you may have heard of, but an atom is what you find in the periodic table. They're not charged. And if they're not charged, if they're not charged, that means that the protons and the electrons, they're the same number of both. And so let's just draw the electrons outside. So the electrons buzz around the nucleus. So we're going to have electrons, 6 electrons, equal to the number of protons. I'm going to draw them as crosses. 1, 2, and then 3, 4, 5, 6. And this is a carbon atom. So this is carbon. That's a lot of information in a short amount of time, so I'm going to run you through exactly what a proton, neutron and electron is to start with. Now, protons and neutrons, you can think of them as being the same size. So if you had a football, if you had 2 different coloured footballs, that would be the protons and the neutrons in the nucleus. A proton, the P stands for positive. So protons are positively charged. And we give them a generic +1 charge. So this is charge, this column here. The neutrons are neutral. Okay? So they're not charged, they have a 0 charge. So protons and neutrons are pretty much the same thing, but it's like if you had 2 footballs and one of them gave you an electric shock when you picked it up, that would be your proton, and exactly the same football which didn't give you an electric shock when you picked it up, that would be your neutron, okay? And they're found in the center, think of it as a center circle, in the nucleus of the atom. Now the electrons are way, way smaller than the protons and the neutrons. They're not the same size at all. They're much smaller, about 2,000 times smaller. And they are buzzing around in these blue circles here, which are known as electron shells. So these things are known as shells, or electron shells. You'll also see them called energy levels. Energy level and electron shell mean exactly the same thing. So this here is your first electron shell, or your first energy level. This second one, with the arrow on it, is the second energy level, or the second electron shell. They are interchangeable, so it's up to you. And overall, an atom is neutrally charged. An atom doesn't have an overall charge. So, the number of electrons and the number of protons are the same, so that means electrons must have the same and opposite charge to the protons. And of course they do, so we give them a -1 charge. So if you think you had one proton, you'd be +1 charged. If you then added one electron, +1 and then -1 will give you an answer of 0. And then I could add 1,000,000 neutrons in there if I wanted to, but that wouldn't change the charge at all because neutrons aren't charged. Okay, now the shorthand way of writing this carbon atom is carbon 12, and you might see it written as this. Now, there are two numbers here. Obviously the C is your chemical symbol for carbon. This tells you explicitly that you have a carbon atom. Now these two numbers here, they give you some information. Now the bottom number is known as your atomic number. Atomic number. Sometimes it can also be known as the proton number, so I'll put that in brackets here. Proton number. And surprise, surprise, that's because that tells you exactly how many protons you have. Don't be fooled in thinking this tells you how many electrons you have, because the definition is protons. If we were to move electrons and form a carbon ion, which is a charged substance, it would still have the same atomic number. And so make sure you remember that this tells you proton number. In an atom, the proton number will equal the number of electrons, but we can remove the electrons in a chemical reaction. Okay, now the top number, sometimes these numbers may be the other way around. Sometimes you might have the 12 on the bottom and the 6 on the top. But the atomic number is always smaller or equal to the next number, which is known as the mass number. The reason I say smaller than or equal to is because hydrogen, I'll rub this out in a second, hydrogen is normally 1, 1 because it doesn't have any neutrons. And so therefore it's not always bigger, sometimes it could be the same. But your atomic number, your number of protons, will never be smaller than your mass number. And that is because the mass number is protons, so your number of protons, plus your number of neutrons. Should have really done this in a different colour, but you can see it there. Protons plus neutrons. In this case, it's 12 because we have 6 protons, and we've also got 6 of these green dots, which are neutrons. So 6 plus 6 is 12. I could actually have a different version of carbon, do it in a lighter colour. It would still have 6 protons. It could have a mass number of 13. And that means that 6 protons plus your number of neutrons is 13. 13 take away 6 will give you 7. So the number of neutrons in this case would be 7. And so the number of neutrons in an atom can actually vary without changing the substance itself. Okay, let's just get rid of that. Now, important there, I said the number of neutrons can change and the substance will still be the same, but the proton number can't. And that is because this number tells you exactly which element you have. On a periodic table, the only element with a proton number or an atomic number of 6 is carbon. No other element can have a proton number of 6. If another atom turned up with a proton number of 6, you know that it is carbon. By the same token, the only element with a proton number of 1 is hydrogen. So that is hydrogen, this is also hydrogen, and this is also hydrogen. So you can have different mass numbers which tell you how many neutrons you've got, but the proton number tells you specifically which element that you are dealing with. Okay, perfect. So I'll quickly talk about electron shells. Now what an electron shell actually is, it's not like the shell of a tortoise. An electron shell is basically, it tells you where these electrons are found. And they fill up in order. So as an example, a hydrogen atom, let's make some more space. A hydrogen atom is going to look like this. Shorthand, I don't have to draw the neutrons and the protons, I can just write the chemical symbol. Now the first electron shell is going to be here. Now hydrogen has a proton number of 1, and therefore it has 1 electron as well. And so the electrons are going to go here. And that is your electron configuration of hydrogen. How about lithium? Lithium has a proton number of 3, and I'm saying it has a mass number of 7. We don't care about that for now because we're not going to draw the neutrons in. So if I had lithium, the first energy level, or electron shell, is going to fill up because this is the one, well, this is the first energy level, so you fill up in order. Now the first shell, so shell 1 or energy level 1, they're the same thing, remember. Shell 1, how many electrons can that fit? So electrons, it can fit 2 electrons. So this is now full up. You can't fit any more electrons. So if I went like this, that's actually wrong. Okay, so what we're going to do now is we can't fit any more electrons in here, and so we move to shell 2 or energy level 2. And then this one starts filling up. And lithium only has 3 protons, so it has 3 electrons, and so we only put 1 more electron in there, and this is the electron configuration of lithium. Now the second shell, or energy level, so let's say shell 2, how many electrons can that fit? It can fit 8 electrons. Okay, so it can fit 8 electrons in this outer shell. And let me give an example of an element which has exactly that. Neon. Neon has a proton number of 10 and a mass number, it doesn't really matter, let's just pretend 22. Okay, so if I was to draw neon, the first energy level or electron shell would fill up first, and then the second shell, here we are, this can fit 8, and I have 8 electrons left over because I've taken 2 from my 10, and so it fills up like so. It's common to draw electrons in pairs like this on your second energy level, but you won't be marked down if you don't do that. So this is your entire electron configuration for neon. You have 2 electrons on the inner shell and 8 electrons in the outer shell. Okay, the last one that you're expected to know is shell 3. Shell 3, and very easy, shell 3 also contains 8 electrons, or 8 electrons maximum. So one more, or the next element along from neon, this will work out quite handy actually, is sodium. Sodium has a symbol Na, so I could easily just rub out the E here. So sodium has a proton number of 11 and a mass number of 23. So this, let's rub out the E here, turn this into sodium, boom, there we go. So now we've got a sodium atom. This is still a neon atom. I've changed the symbol, but I need to add another electron, don't I? So the first 2 energy levels will fill up first, or electron shells, they will fill up first. So that now they are all full, I need 1 more electron because I've got a proton number of 11 and not 10. So 1 more electron, we'll just put that in the 3rd energy level, and this is the electron configuration for sodium. Okay, so lastly, what I want to quickly show you is the periodic table and how it's organised. So let's take a quick look now. Here we go. Right, and so we have these numbers at the top. And so we have 1 there, 2, and now ignore all of this. Ignore all of that. This is 3, 4, 5, 6, 7, and then this last one is either 8 or 0. It doesn't really matter. So we're just going to say 8. Now, these groups, what they tell you, so 1, 2, 3, 4, 5, 6, 7, and then 8 or 0, what they tell you is how many electrons that the atoms have in their outer shell or energy level. For example, hydrogen here is in group 1. And if we go back up, we can see, back up a bit further, here we go, that hydrogen has 1 electron in its outer shell. And, well, conveniently enough, all 3 of these are in group 1 because lithium, I have 1 electron there in the outer shell, and sodium, I have 1 electron there in the outer shell. What about before when I had neon? Well, neon is down here, and it is on the far right there in group 8 or group 0 because it had 8 electrons in its outer shell, or you could say it had 0 electrons in the one after. So that's why it's either group 8 or group 0. Okay, and then lastly, carbon here. We have 1, 2, 3, 4, and so carbon should be in group 4. Let's make sure. Here we go. Carbon is found in group 4. So it's very handy actually that the elements are grouped in this way. It means that a lot of them have similar characteristics in their groups. So group 1 is all of these elements here. Group 2 is these. These here are called the transition metals, and they are not found within any groups. These do not count as groups. This is group 3, group 4, and so on. 5, 6, 7, and then group 8 or group 0. Okay, so that's the arrangement of the periodic table. Obviously you can see that they're also, let's do this in a different colour quickly. You can see that they also have the atomic number. So here, got that arrow there, you can just about see it. You have the atomic number 1 of hydrogen. And then here, there we go. You've got the atomic number 2 for helium. And then we'll have 3 down here. 3 for lithium, 4 beryllium. And so the way the periodic table is structured is that we are going up in atomic number each time we go across 1. So 3, 4, and then we move 5, 6, 7, 8, 9, and so on. The other number is basically the mass number, but it's worked out as an average. And we'll come on to that in the second part of your course, and that's called the relative atomic mass. You don't need to worry about that for now, but it's basically just an average of different atoms' mass numbers. So we've had a look at what the mass number is. We know what the mass number is. It's protons plus neutrons. Because elements can have different number of neutrons, we take an average, and that's why sometimes you'll see it with a decimal point. Okay, so that was a lot of information in a short period of time. So please do pause the video, rewatch at your own pace. And also, I've got links below. You can send me an email or just write a comment in the comment box below, and I'll do my best to get back to you. So thanks for watching, and I'll see you in the next video.